All right, everybody, I want to work on problem 7, part C. I'm going to finish up this page in this video. So we have an object that falls from a cliff that's 30 meters high from rest. Let me just, I like all these little note card ideas that I have here. So I'm actually going to take all of this and try to move it to the other side. This may or may not work. Let's just see. Oh, perfect. All right, so right here. We don't need this. All right, perfect. So here's the idea. Our initial position, again, is always 0. We fall 30 meters. We fall from rest, so our initial velocity is 0. And we are falling, so our acceleration is 10 meters per second squared because of gravity. So let's get the speed right before it hits the ground. We can say v equals at plus v naught, for example. I deliberately chose this equation because look, when I put in the numbers, I'm going to get v equals 10 times t plus 0, and I see that doesn't work. So I move to the next equation. Let's see if we can get the speed using the equation that has no time in it. So v squared equals v naught squared plus 2a x minus x naught. Let's put them to numbers. So we're going to have v squared equals 0 squared plus 2 times 10 times 30 minus 0. So that's going to give me v squared equals 600. And that's going to give me a value for v when I take the square root of that's going to be like square root of 6 times 10, which is, let's just see, 24.5 meters per second. All right. And now I can go ahead and use the formula v equals at plus v naught. So that's going to be 24.5, I'll just put a box around that, equals 10 times t plus 0. When I simplify, dividing both sides by 10, I'm going to get t is 2.45 seconds. All right. Now I'm going to move on to problem D. It says a car initially traveling very quickly slams on the brakes. One thing I want to be clear on, it says braking acceleration. So one other little hint here. If you see the words braking acceleration, braking acceleration means put a negative sign in front of the A, in front of the acceleration. So in this case, for example, and it skids to rest. So V final is 0. We don't know the initial speed. X naught is always 0. 50 is how far it travels for. The acceleration is negative 2.5, and we don't know the time. So let's get the time it takes. Actually, we don't know. So it says what was its initial velocity before the driver slammed the brakes. So let's see what we can do. So v equals at plus v naught. Well, we don't know the time and we don't know this, so that's not going to work. All right, let's try using v squared equals v naught squared plus 2 times a times x minus x naught and putting in our numbers. So 0 squared equals v naught squared plus 2 times 2.5 times 50 minus 0. Negative 2.5 right there. So I'm going to get 0 equals v naught squared plus, that's 5 times 2, negative 250 right here, all in parentheses. So I'm getting v naught squared is 250, or v naught is 15.8. All right. Meters per second. Awesome. Now, let's get the time it takes to come to rest. So I could do V equals AT plus V naught. So 0 equals negative 2.5 T plus 15.8. I'm just going to skip to the answer here. I'd like to see you solve this. You're going to get a time of 6.32 seconds. All right. So that is problem 7, page 2, problem